Hello again. In the previous lesson, we introduced what a function is. We learned that a function is a rule where each input has exactly one output. In this lesson, we're going to focus on two skills. First of all, we're going to learn how to evaluate functions. And then secondly, we're going to find the domain of a function. So let's begin with the quick rules for today. First of all, in terms of the quick rules that I feel like are the most important in this lesson. It is when you see f of a, it means substitute a for x and simplify. So, in other words, whereas it's typically f of x equals, in this case, we're going to say, suppose x equals a. Well, what you're going to do is you're going to substitute a into x. Okay. Next, for algebraic inputs, replace every x with the expression and then simplify. Where you see denominators of rational domains, you need to understand that the denominator can never be zero. And then whenever you see a radicand, just understand that we're going to write that using an inequality symbol. And then just to kind of show you, if you are dealing with a rational domain, we're essentially saying that the domain, which is b, cannot be equal to 0 with respect to the domain. Okay, so let's begin with the first problem. The first problem is given f of x equals 2x plus 5, we're going to find f of 3 and state what the notation f of 3 means in words. Okay, so the notation f of 3 means that we are finding the output of the function when the input is 3. So notice the input is 3, so we're putting a 3 into the machine. And then we need to figure out what the output of the machine would be. So if we were to write f of x equals 2x plus 5, and I just want to make sure I'm using the proper equation up here, okay? So I want to substitute the 3 into the x. So f of 3, and then that's 2 times 3 plus 5, okay? From there, I'm going to compute. This will be 6 plus 5, and the final answer is 11. So when we replace the x with 3, the output is 11, or when the input is 3, the output is 11. Now, what does this mean in words? In words, it means that f of 3 means the value of the function when x is equal to 3. And that's it. Next, let's look at example 2. So given g of x equals x squared minus 4x plus 1, find g of negative 2 and g of a plus 1, and then simplify completely. Okay, so let's begin with the first part. Okay, so we're going to find g of negative 2. All right, so our original equation is g of x. I just want to rewrite it, make sure I'm using the proper equation. X squared minus 4x plus 1. Okay, and I'm going to substitute the negative 2 into the equation. So g of negative 2 equals negative 2 squared minus 4 negative 2 plus 1. Okay. So when we substitute this, we can evaluate it. So this is negative 2 times negative 2. Negative 2 times negative 2 is going to give me a positive 4. 4. And then this is negative 4 times negative 2. Negative 4 times negative 2 is a positive 8 plus 1. Adding these together, we have 12. 4 plus 8 is 12, plus 1 is 13. So when the input is a negative 2, the output is going to generate 13. Now let's look at part B. Part B is, okay, so part, it's the first part, and then part B, which is g of a plus 1. Okay, so g of a plus 1, I'm going to go ahead and write this out so I won't run out of space. G of 1, or excuse me, g of a plus 1. Now, we're going to evaluate g of a plus 1, but this time the input is not one number. The input is an expression. So what it means is every x becomes a plus 1. Okay? So whereas the original was x squared, so it's going to be a plus 1 squared. And then the next is minus 4x, so it's going to be minus 4a plus 1. And then plus 1. Okay, so notice I just substituted. So the original was x squared. So I substituted the expression for that and squared it. Then this is minus 4, parentheses a plus 1, and then plus 1. Okay. Then from here, we need to compute this. So the first thing we want to do is expand and simplify. So I'm going to write up here. This is, if we expand on this, this is saying that we have a plus 1 times a plus 1. And we can use the FOIL method. The FOIL method is outer. So that'll be a times a plus a times 1, which is a, plus a times 1, which is a, plus 1 times 1, which is essentially 1 squared, or 1. So this will generate a squared, and then this is 1a plus 1a, which is 2a, plus 1. Okay, so this is a squared plus 2a plus 1. A squared plus 2a plus 1. And then we're going to use the distributive property here. Negative 4 times a is negative 4a. Negative 4 times 1 is negative 4. And then we're going to tack on that plus 1 there. Continuing further, we have a squared, because this is the highest power. There are no other powers of 2, so we cannot add this to anything. We do have two terms that are the same. We have a negative 4a and a positive 2a. These two subtract because you have to combine like terms. So this will generate a negative 2a, right? And then we have a positive 1 and a negative 4 and a positive 1. Okay, so essentially this is plus 1 plus 1 minus 4, which is negative 3. Negative 3 plus 1 is subtraction, so that'll be negative 2. Okay, so when g is the expression a plus 1, the final result is going to generate a squared minus 2a minus 2. Okay, and so this is my final answer. So the important skill here is substitution. Whatever is inside the parentheses becomes the input. Okay, now pause the video and try this example here. All right, so we're given q of x equals x squared plus 3x minus 4, and then we're going to find these two. So let me go ahead and write this expression here just so I'll know that I'm using the proper equation. Okay, now I'm going to substitute negative 2 inside the equation. So negative 2 equals negative 2 squared plus 3, negative 2 minus 4. So notice all I did was substitute the equation for wherever I see x. Negative 2 times negative 2 is going to give me 4. Positive 3 times negative 2 is going to give me a negative 6 minus 4. Using the order of operations, 4 minus 6 is going to give me negative 2. Negative 2 minus 4 is going to give me a negative 6. Okay? So when g of x is g of negative 2, the output is negative 6. Okay? Now we're going to find q of a. Okay? So when q, or when x is a, we essentially substitute a in there, plus 3 of a minus 4. So notice we're using just a variable, just a generic variable this time. So this is a times a, which is going to be a squared plus 3 of a, or 3a minus 4. Okay. So since a is already a variable expression, there is nothing else to simplify. Okay. So we cannot combine like terms. That is it. Okay. Let's continue. All right. Now, when we're looking at example number 3, as a matter of fact, okay, when we're looking at example number 3, we have uh, here it says find the domain of each function and then state the restriction and write the domain in interval notation. Okay, so we have a, which is hx equals x plus 4 divided by x minus 3, and then we have p of x equals root 5 minus 2x. Okay, so let's first of all deal with the rational function. Okay, this is a rational function. Anything written as a over b is considered rational. Now notice the the denominator is x minus 3. So in order to find the domain, we essentially are going to set the denominator of a rational function equal to 0. So a, we have x minus 3. We're going to set that equal to 0. Add 3 to both sides. X is going to give me 3. So this tells me that x cannot be equal to 3 in this denominator. So if x cannot be equal to 3, okay, and essentially we can just, if you want to, you can go ahead and write the cannot be equal on this expression because that's essentially what it says. So the domain of part A is all real numbers except for 3. So if we were to write this, it would be written as negative infinity, comma 3, union 3, comma positive infinity. Okay, so the domain is typically always negative infinity to positive infinity, and that just means all real numbers. But when there's an exception to the rule, like this case, we can't have the denominator of positive 3, otherwise the denominator would be 0. Then you need to write it in interval notation, which is negative infinity 3, union 3, infinity, positive infinity. Okay. All right. Now let's look at part B. Okay. So all we're doing is finding the domain of each function in this case. So for a square root function, the radicate must be greater than or equal to 0. Okay. So um, what we have to do is use this expression, which is 5 minus 2x, and we're going to write that as being greater than or equal to 0. And remember, earlier I said if you see this, if you see a function that's written like this, then you're always going to use this expression here. Okay, so that's what I'm doing here. Then I'm going to subtract 5 to both sides, minus 5. That leaves me with negative 2x greater than or equal to negative 5. And then I'm going to divide both sides by 2. Anytime you divide by a negative coefficient, then your sign flips. So it's going to become x is less than or equal to positive 5/2. Okay, so because we divided by a negative number, the inequality sign changes direction. Okay, so the domain is all real numbers that are less than or equal to 5/2. So the way we would write the domain in this case is negative infinity, comma 5/2. Okay, because again, all the x's must be less than or equal to 5/2. 5/2 is the cap. This is why we use the bracket. Okay. Now, this says let f of x equal 2x plus 1, and then first find f of 3, then solve f of x equals 3, and explain why these are two separate equations. So first of all, let's find f of 3. So the first one is f of x equals 2x plus 1. And then again, we're substituting 3 into the expression. So we have f of 3 equals 2 of 3 plus 1. F of 3 equals 6 plus 1. F of 3 equals 7. Okay, so that's the outcome when we use an input of 3. Now, what happens when we set the function equal to 3? Notice this is f of x. So this is saying take the function, which is 2x plus 1. So the 2x plus 1, and we're going to set it equal to 3. Okay, when you do that, you subtract 1 to both sides. This will give me 2 equals 2x. Divide by the coefficient of 2. X is equal to 1. So notice, after computing this, we have 7, f of 3 equals 7. And then after computing the other one, we have the solution of x is equal to 1. So f of 3 asks, what is the output when the input is 3? But f of x equals 3 asks us, what input gives an output of 3? And so 1 would be the case. So if we put in 1, well, guess what's going to come out? 3. If we put a 1 in here, out comes a 3. Okay, and so those are two different questions. Okay, just to kind of show you the difference between the two. This one is asking you to use an input of 3. This one already gives the output and then asks us to find the input. Now, common mistakes. So don't forget, you need to combine, um, do not forget combined domain restrictions. So for Rx equals root x minus 1 divided by x minus 4, a student says that the domain is blocked at 1 or capped at 1 and it tends to infinity. Is that complete? Correct the domain and explain the missing restriction. So the student noticed the root, and that part is good because we have root x minus 1, and the radicand must be greater than or equal to 0. Okay, so we have x minus 1 must be greater than or equal to 0. So that's essentially saying that we have x is greater than or equal to 1. Okay, so far that gives us 1 tends to infinity, right? So far that gives us this. But the function also has a denominator, okay? The denominator of x minus 4. So the denominator cannot equal 0. So the denominator is x minus 4, and it cannot be equal to 0. So we add 4 to both sides. Then we'll get x equals, or excuse me, x cannot be equal to 4. So if x cannot be equal to 4, therefore the student's answer is incomplete, okay? So the student's answer is incomplete. The domain starts at 1, but we must remove 4 from this situation. So the correct domain is 1, 4, union 4, infinity. Okay, so this would be the correct way to write the domain. And so this is the key lesson. When a function has more than one restriction, the domain must satisfy all restrictions at the same time, not just one. Okay, so let's review the main ideas. We looked at f of a. It means sub a or x. Okay, we also looked at f of 3, and that means an input of 3. We also looked at f of x equaling 3, which means an output of 3. So you need to solve for x. And then we also looked at a radicand function. So that essentially says that the denominator is not equal to 0. Okay. And then we looked at, excuse me, that should be, actually, that is the radical function. Okay. Or the rational function. A rational function cannot have a denominator, and then the radicand, we looked at that as being the radicand must be written as greater than or equal to 0. Okay, but you can drop the radicand over here if you have if you have a radical, just drop the radicand over here and then compute it as follows. So when evaluating a function, you need to replace every x with the input and simplify. Okay. And that concludes this lesson. And thank you for watching, and I'll see you in the next one.